Hi friend, welcome to the abstract algebra class. It is class 27. In this class we will prove a theorem, uh, theorem unnecessary and sufficient condition for a non-empty subset H of a group G to be a subgroup of G is that H into H inverse equal to H. A non-empty subset H of a group G is subgroup of group G if and only if H into H inverse equal to H. We now prove the theorem. Let's analyze the theorem. Let G be a group and H be a non-empty subset of G. H be a non-empty subset of G. We have to prove that H is a subgroup of G if and only if implies H into H inverse equal to H. We want to prove this statement. First, suppose that left hand side is true. Then we prove right hand side. First, suppose that H is a subgroup of G. H is a subgroup of G. We prove that the right side of the theorem. H into H inverse equal to H. We prove that H into H inverse equal to H. Let E be the identity element in G, and H belongs to H. Small h belongs to H. Then H into H E inverse belongs to H into H inverse. Here H belongs to this H belongs to H, and E inverse also belongs to H inverse. Therefore, H into H E inverse belongs to H into H inverse. E is the identity element in G, so E also is identity element in H. E inverse also is an element of H inverse. Implies H into E inverse. Here H into E inverse equal to H, E inverse equal to E. So H into E equal to H. Therefore, instead of H into E inverse, we put it H. H belongs to H into H inverse. Therefore, H belongs to H inverse, H, and H belongs to H into H inverse. Therefore, H belongs to H implies H belongs to H inverse. H into H inverse implies when H belongs to H belongs to H and into H inverse implies H belongs to it's a subset of H into H inverse. We call relation 1. Let X belongs to H into H inverse. H into H inverse, we can write H into H inverse equal to A into B inverse, such that A belongs to H. This A belongs to H, and B inverse belongs to H inverse. B inverse belongs to H inverse. Let X belongs to H into H inverse implies X equal to H into H inverse. So we have from here we can write A into B inverse, where A belongs to H, B inverse belongs to H inverse. When B inverse belongs to H inverse, B belongs to H. Since A belongs to H, B belongs to H and H, and H is a subgroup. Here we say that first suppose that H is a subgroup of G. A belongs to H, B belongs to H, and H is a subgroup of G. Therefore, A into B inverse belongs to H. Implies A into B inverse. A into B inverse is the value of X. It implies X belongs to H. We get X belongs to H into H inverse. X belongs to H. X belongs to H into H inverse implies X belongs to H. This implies H into H inverse subset of H. Here X belongs to H into H inverse. We prove that X belongs to H. That is, X belongs to H into H inverse implies X belongs to H. both implies H into H inverse subset of H. We call relation 2. From relation 1, H subset of H into H inverse and H into H inverse subset of H, we conclude that H into H inverse equal to H. This proves the first part of the theorem. Converse, suppose here we have two parts. One, if it is first part and it is second part. First part, we suppose that H is a subgroup of G. We prove that H into H inverse equal to H. We converse, we now suppose H into H inverse equal to H. We prove that H is a subgroup of G. Suppose H into H inverse equal to H. We have to prove that H is a subgroup of G. Let X belongs to H into H inverse. H belongs to H into H inverse. Implies X equal to, instead H we can write A, and instead H inverse we can write B inverse. Where A belongs to H, B inverse belongs to H inverse, B belongs to H. Since H into H inverse equal to H from here, implies X belongs to H into H inverse, X equal to A into B inverse. Then when X belongs to H into H inverse, implies X belongs to H, since H into H inverse equal to H. Implies instead of X we can write A into B inverse belongs to H. Implies H is a subgroup of G. In previous classes, class 26, we proved that H, if H be a subgroup of a group G, then A into B inverse also belongs to H. Now we have A into B inverse belongs to H. This implies H is a subgroup of G by class 26, which it was our last lecture. Therefore, H is a subgroup of G if and only if H into H inverse equal to H. Hence, proof. The theorem was this, and we prove the theorem. Thank you.